Okay, so I wanted to give like a quick little like review problem because this has been kind of a longer unit compared to our previous couple units. So I thought it would be a good idea to kind of go back and review some of this derivative stuff that we were talking about earlier in the unit. Just kind of help out a little bit. Mostly, the lesson that we're coming up on is about your AP presentations. So I have this particular problem that I'm going to talk about. It's from Finney 141, page 141, number 37. The position x coordinate of a particle moving along the line y is given by that equation, where t is time in seconds. So I want to describe what the particle is doing. So I also made a Desmos graph to kind of help describe what's going on in this function. So here is the one that they gave me. And then I also drew the line y equals 2, because what the problem is telling me is how this particle is moving left and right along this line. So it's not a point, it's a particle. It's not moving along this graph. It's like moving left and right along this line. So down here where time is at 0, we're all the way back over here at -5. And then once we reach this point up here, it gets really, really high. So it gets to like 6. So it shoots all the way across the screen. And then it shoots back until it gets to down here where it is at, let's see, -2. So it started here, shoots all the way across to 6, then goes back to -2, and then it shoots all the way to infinity, because after this point, it just keeps going farther and farther away. So we could write that out as the, I said it all, so I'm not going to necessarily write it all. The particle starts at -5, 2, then moves to 6, 2, then it turns around to go back to -2, 2. Then the particle will grow constantly to infinity. I was reading off of my notes thing, and then I figured, just post there. That's what I just said, but all written out, because sometimes it's nicer to see it rather than hear somebody say it. Anyway, when does the particle speed up? When does the particle slow down? So the function that I'm given up here is my position function. So it's telling me where the particle is, but it's not telling me its speed. In order to figure out its speed, I first need to figure out what its velocity is. So to find the velocity, I need to find x prime of t. So that is going to be 6t squared minus 26 t plus 22. So that is going to tell me the velocity of my particle. However, it's not going to tell me its speed. In order to find its speed, I need to do the absolute value of that function. And you can actually do that on your calculator. If you type in abs, so it is under math, you can find absolute value and then type in your function. I'm just going to write x prime of t. And then you can get this cool graph. Here, check it out. Look, there's my cool graph. Hooray! I'm going to zoom in a little bit on that so we can see it a little bit better. But this is telling me the speed of my particle. So the particle is speeding up when the slope of this line is positive. So if it is getting bigger, that means my speed is increasing. So if the slope of this line is positive, it is speeding up. So that is happening right here, and it is happening right there. My particle is slowing down when the slope is negative, when the graph is going down. So here's a section where it's going down, and then here is another section where it's going down. So that is where it is slowing down in green and where it is speeding up in blue. But I need to tell the problem what are those specific times. And I can do that all on my calculator because this is a calculator problem. So here I've got it graphed onto my calculator. I adjusted the window a little bit so that I could see it. A quick question in case you were curious where that absolute value thing is. It's under math and then over to num and then ABS. And when you type it into the calculator, if you've got math type on, it'll use this nice function. Anyway, so I need to figure out when this thing is changing. So I need to figure out what is this point right here. I am going to calculate a 0 between those two spots. So I've got one between there and here. So 1.528. So that is where it starts to speed up. And then I would do the same thing for this one over here. I also need to calculate this maximum where it is turning around, where this thing, yeah, I gotta find that maximum. So second calc, I need the maximum, please. So somewhere between there and there. So my maximum is at my x value of 2.667. I don't really care about the y value, I care about the x value. So I've done that. I've written those numbers down on my piece of paper. Now I want to describe that on my paper. So I want to say that it speeds up in those blue parts. So it speeds up from 1.153, I got that off of the calculator, is less than or equal to t, which is less than or equal to that maximum that I just found, 2.167. It also speeds up in that second spot. If you do the 0 to find that second spot, you find it to be at 3.180. So the second spot that it is speeding up is when t is greater than 3.180, because after that point, it just continually gets faster and faster and faster. Right. When are we slowing down? So it slows down from 0, which is less than or equal to t, which is less than or equal to that spot where it stops, which is at 1.153. It is also slowing down in that second green chunk, which starts at 2.167. And it keeps doing that until it reaches its speed up spot at 3.180. Now we kind of already checked this because that's where it's like kind of slowing down. We want to figure out when it changes direction. So it changes direction when it goes from slowing down to speeding up. So whenever it crosses our x-axis, so whenever we're crossing the x-axis right here. So those are our two x-intercepts, which we just found. So that is t equaling 1.153 and t equaling 3.180. Great. Same problem, kind of different sort of questions here. So when is the particle at rest? The particle is going to be at rest because remember, it started at 5 and then shot all the way across the screen and then shot all the way back and then it went in another direction. So when it hits that 6, it's kind of at rest for a minute, and then when it comes back, it rests for a minute before shooting off to infinity. So we want to see when it hits that 6, when it hits that -2, those are our 2 moments of rest. We can see that when it crosses the x-axis, so when it changes its direction. And those are the same times that we were just asking. So the question of when the particle changes direction is the same question about when the particle is at rest. So they're the same question, different words. So this one is t equaling 1.153 and t is approximately 3.180. And these are in seconds. Okay. So we want to describe the velocity and speed of the particle. So I kind of typed this one out. So what's going on with our particle? The velocity starts positive. We start out with that big positive velocity. So I have this big positive velocity, but it becomes negative. So it kind of like shoots down. The velocity does become positive again later because we had this negative velocity in all of this time, but eventually it becomes positive again as it's shooting away from the y-axis. The speed starts to decrease, um, decreasing from to zero at t at 1.15 seconds. So that was that resting spot, and increases until t equals 2.17. So that is that kind of turnaround spot. So we have this negative, 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 and then it starts heading back the other direction. And then it will increase after that. All right, don't need Jubo anymore. When is the particle at the point 5,2? So we need to figure out when it is at a particular spot. So we need to figure out when the position function, and when 2t to the third minus 13t squared plus 22t minus 5, we want to see when the position function equals 5. Because remember, it's shooting left and right along this line too, so we don't want that. So we want to figure out when it is going to equal 5. So we can go to our graphing calculator. And actually, I'm going to do this one on Desmos just because it's going to be a little bit easier off of my Desmos graph. So we want to see when this value ends up equaling 5. So I don't need this one anymore. I'm going to say, when is it spitting out the value of 5? So y equals 5. So now it's just a matter of finding the intercept of this thing with the value of 5. So we get one of them at 0.745 seconds. We get another one at 1.626 seconds, and a final one at 4.129. You can do that on your calculator if you have that second function in. This is the wrong one, so this is with the derivative function. So I don't want to do it with the velocity. I don't want when the speed is 5, I want it to be at the position of 5. But to find it, just a quick reminder is it goes second calc, and then you want the intersect 5. You choose your two curves, but you want to make sure that you're close to where you want that intercept to be. So this one, enter, and then the other one, enter. And be close to where you want to find it. So I get an intersect there. If I wanted to calculate it at a different spot, I want this one and this one. And when I'm guessing, I want to make sure I'm really, really close to the spot that I'm looking for so it can find the intersect at the spot that I'm looking for, especially since this one has 3. But yeah, it has 0.745 seconds, 1.626 seconds, and 4.129 seconds. Oof. That's it from me. That's all I got. Thanks for watching this bonus video review. I hope it was helpful, and I'll see you in class. Bye-bye.